Hello guys, welcome to another tutorial. So we're gonna go over procedural generation with seeds. So let me show you a new game with that seed. And it takes a while to load. So here we are. This one random world I made. I did a bunch of like other stuff, made some rocks. You can hit them. I know I'm using a regular axe to hit a rock, but that's so it is. And I have this house that gets procedurally placed here, and that's pretty much most of it, and the floor as well. So I'm not gonna go over how to do like wavy mountains. I'm just randomly moving the vertices. So that's beyond the scope of the tutorial, or the scope of my brain, I guess you could call it. I'm still trying to learn it myself, like sine waves and stuff like that. So right now I'm just randomly moving the verts on the y-axis up or down, and the rocks are being placed using raycasting. So they're placed up in the sky and then put down to the wherever they touch first. Alright, so let's change, and I also have save and quit. So I have this here. So since it's using seeds, you already know what a seed is gonna result in. So I have not world, Earth. So Earth 2.0, no spaces. So before I even start it, I'll let you know what it's gonna look like. So I'm gonna start under a tree, and if I turn around, the house is gonna be a bit down further. So I already know what happens with this seed. So that's how procedural generation works. So let's say new game, it uses that seed. There you go, I'm under a tree, and then if I turn around, there's a house over there. So everything's all the same. So I hit this rock, and I even have a save system. I'm gonna save that for a second tutorial, a part 2, for how to save data for procedural generation, so it doesn't spawn back the same stuff again, and whatever it removes stays removed. Alright, let's get to it. Alright guys, so here I have the player, and then I have the house. So I have these in the world because I just placed them when the game starts with the procedural placement. And then I have a terrain mesh with an array mesh on it. So that's what we're gonna modify for the height, procedural. Then I have a light and a camera for top view. I had it there just to show, like, how the world looks from above. And I can right click to look at it. I forgot to show that before. And that's about it. So let's create a script on main. You could call it, let's put it in the scripts folder. Let's call it a generator. Generator. Open, create. So what do we need? First, we're gonna need the string. World 1, 2, 3. Okay, so the way how Godot works with procedural generation, you have a seed variable. You could set a seed manually. So let's make a var, and then we call it maybe the current seed. Make that be 0. So right here we get the current, we say seed, so we get the hash value from it. And then now with Godot does most of the internal stuff with the random placements. Like, so for example, when we have a seed that's internal to the randomization system, or what they call it. You could put the current seed in there. So let's, for example, try something. Let's say print maybe rand range maybe from 0 to 100, and save. So let's just run this scene. See what happens? So if you see it prints 2.16, 2.608 blah 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 blah. So let's quit out of that, and that should print the same thing again because we're not changing the seed. So let's do that again. Yep. I meant to run this scene. There you go, same number. It's gonna always print the same exact number until we do something about here. Let's say just something different, and then I can run it again. Now it prints 34.4, and stop, run again, same thing again. So you get where this is going. Alright, so next we're gonna start placing stuff. So these are all the stuff we're gonna do. We're gonna get the rocks and the trees, and we need a reference to the mesh. Unready for terrain equals terrain. Then we're gonna export world size and then subdivisions. So that's for the mesh. These are gonna be for the random placements. So I limit them to be maybe, you know, it doesn't go all the way to 700. So I could increase these if I need. And tree count is the amount of trees I want to spawn, and rock count, the amount of rocks. So for land complete, this is for using the ray casting, because if I do everything in one go, it doesn't work. So I check it in the process method after I create the land. So then I do these afterwards, if that makes sense. And the offset value now is for the player. So let's bring that up a little bit, as it sometimes doesn't work. Whenever the player gets placed, he might fall through the world because the ray is cast directly down to the floor. So I've used the Y value to bring back the player up a little bit. Okay, so let's go create a function, generate world. Okay, so first we need an array mesh to create that, and then we need a regular mesh. We're gonna use that to modify the array mesh. So for the mesh, we set the size to be the world size, so X and Y, because it's a plane we're using. And then for the subdivision, depth and width, the subdivisions value here. So for the array mesh, we add a surface from arrays, then we get the mesh type to be a primitive triangles, then the mesh, we get the arrays from the regular mesh. So that's the only reason we needed that mesh for. And let's go back up here. Let's export a material. So material, and say land mat. So what I'm gonna do is I'm just gonna have a plain like material, maybe with just green. That's what I had before. And then we can come back here and say a mesh surface. So it's surface material, and let's say land material. Alright, so now to modify that mesh, we're gonna need a mesh data tool, and then we instance it, and then get a create from surface from the a mesh. And what we're gonna do now is loop through all the vertices. So for I in range, and we say mdt at get vertex count. We go down. So say var vertex is equal to mdt dot get vertex at I. Now this is where we change the value of the vertex. So vertex dot y equals rand float, or I should say increment, not equals, rand float times a value. So we need maybe, let's see, did I have it here? No, I didn't. So let's create that. A constant, fill it max height. Make that 10. So that's the highest that we need the raise the vertex go. So what's happening here, each time this gets called, it's already predetermined for each loop. So as long as the seed doesn't change, whatever gets called at what point in this loop, that is gonna always be the same. So that's how that works. Then now we need to commit all of it. MDT dot commit. Oops. Where are you? Oh. MDT dot commit surface and mesh, a mesh. Then we need to say terrain dot mesh is equal to, you guessed it, a mesh. And also for the collisions, we need to say terrain dot create tri-mesh collision. And then we could say complete land equals through. And we save. Could go here now and they could test it. We'll say generate land world, sorry. Save and rerun it. Oop, keep on doing that. Don't want to run that. Let's run here. There you go. Nothing showing up. You wonder what? Oh, missed the step. So right here, we need to say MBT set vertex to be vertex. Vertex to be. Oh, let's see that there. Okay, that should do the trick. Let's go back there. There you go. Now we got some thing going on here. But we need to place all of these other stuff. So we have a few stuff to do. Let's go back right here. I'm just gonna get this thing pasted here. So what I'm doing here is setting the normals so you could see the shadows and the curves in the texture in the surface. And then it says save. Could look back at it again. There you go. Should be a little better, but the white isn't helping. So let's add the material. And land material, new spatial. Give it a color of green. Oops. Maybe like that. That should do the trick. There you go. Now you could see the curves. Alright. Now let's generate all the other stuff. So func process. Then we say if land complete. I have it backwards. I should say land complete. So now we're gonna create some function. Let's generate. What should we do first? Generate trees. I could push that down a bit. Say func generate trees. This is basically the same type of function twice. Generate trees for the trees and the grass. I mean the not grass, the rocks. So what are we gonna do here? So var position, we're gonna say equals rand range. So we need to use those min now. Min x min x and max x. Forgot one thing. So vector 3. Then we say put it at 100. So this is gonna be above the world. Then we say range, rand range, close it off. Then we need rotations as well. So now let's go above that and say for I in 3's count. We're gonna instance 3. 3i equal 3 dot instance. Now let's say add child. Okay, and let's say 3 I dot global transform, or could just use transform, but I'll just go global transform. Keep in mind we're gonna use raycast here, so we're gonna have another variable. Let's do that for now. Let's say var fnl pos. It's gonna be equal to position, or sorry, mean get down ray. We're gonna create that function, so it's gonna be used for the, let's copy that, just paste it here for the other items. So func, let's pass on that for now. This is gonna be final position, or let's just render it for now. Let's show you what it is without anything. So where are we? So generate trees. So right after it does all that, we need to set process to false. So we don't want this thing running. This is a bad idea here. I just thought about that. The reason is it's the main scene. It's the parent scene. I think it should be fine for now. But let's say, cause it's the, now let's say boom, save. Now let's run that. And yep, all the trees are up in the sky. Now let's create that array thing. So back to the generator. We can say get down ray here. So what this does is give it a length, how far the ray should shoot, then where we want it to go. So the position that y minus the length, that's the direction. Then get the world state, direct space state, result, and we send result position, else we send 0. So now let's go back in the 3 generation, change this to final position, FNL. Now it should work from the back. So let's go there. Oops, keep doing that. There you go. And now those trees are placed right where they got hit. Alright. That's it for the most part. So let's just copy over the same code. Call it generate rocks. Let's move these down a bit. Call it generate rocks. Then give it the rock, the instance. Okay, now we'll put it right here and say generate rocks. There you go. Now we have rocks being spawned. We could put that house down as well. Alright, so let's go back to here. And say func place house. And we can see, let's go here, grab a reference to the house. So on ready var house equals house. Come back here. Let's say house dot global transform. dot origin equals FNL pos, then house dot rotation degrees equals rotation. Let's save that. Did we set it? Nope, we didn't set it for the house and the trees. So let's see. Now we could come back here and say place house. And go ahead and run it. Alright. And then we now have to place a player. So let's find this house. There it is over there. Alright. You guys get the drift. So let's speed through this part. Alright guys, that's it. So let's run it now. Now we can see it running. Alright, so there you go. So in the next video, we're gonna go over saving. So if I right click, I could look up. You can see the house is down the bottom there. I can't move my mouse right now. Bottom right. If I quit and reload again, let's run again. Remember, we're not using that right now. You look up again, everything's still in the same spot. And the land is actually the same as well too. The floor, I should say. Alright guys, so next video I'm gonna go over saving data. Saving, and then that should be it. I still need to learn how to do sine waves. Sine waves, flow in hills and valleys, stuff like that. That's beyond my knowledge right now. Alright guys, like and subscribe. See you in the next video.